If you're in any way, shape, or form familiar with nuclear energy, you could probably guess what Homer here is eating. Now, Homer's from The Simpsons. He works at a nuclear power plant, and he's eating nuclear waste. But does anyone here actually know what nuclear waste is? What is nuclear waste? Well, it's a bit complicated, but in the simple forms, nuclear energy relies on nuclear fuel rods, like the ones showed in this image right here. These fuel rods are made of elements such as uranium, plutonium, and thorium. They are burned in nuclear reactors, and these, through the process of fission, creates us energy. But they get less efficient as they go on, and this is what creates nuclear waste. Now, there are two types of nuclear fuel I'd like to focus on today. That is uranium dioxide and mixed oxides. But what are they? Now, uranium dioxide is what I like to call UOX in the world of nuclear. It stands for uranium oxide. It's made by creating uranium fluoride 6 or hexafluoride and putting it in gas cylinders. This then converts it into to uranium oxide, which gets pressed down into a fine metal substance, elongated into fuel rods, and then that's what creates the fuel rods I mentioned earlier, that would then go through the process of fission, create its energy, then they turn into waste. But UOX is special. The waste can be recycled, which creates MOX. MOX is mixed oxides. To create them, you include uranium, well, and plutonium. Plutonium being a byproduct of uranium dioxide's nuclear waste. You then combine those two together, you fabricate them, you sinter them, you smash them together, create the rod, assemble the rod, send it to a nuclear power plant, then you have good old energy. But I want to see which of the two are more radioactive. And to measure this, I decided to use the actinide series. These are some of the most common nuclear elements that you will see. You will see the thorium that I mentioned right here, the uranium here, and plutonium right here, which are all fuel sources we would use for nuclear energy. But what does this graph mean? You probably don't know, but I can explain it to you. It's not that difficult. Actinide is just what I mentioned before. It's just a series. And this is what all these elements are from, the actinide series. Radiotoxicity is just how toxic a certain type of radiation is. Now, for this project, I like to focus on ionizing radiation, like gamma radiation, the ones that will smash through your DNA cells and give you cancer. Now, what I'm explaining with these charts are pretty simple. Time in years. Radiation is the decay of an element. So time in years is how long it decays for. And then the units that I use on the side is the correlation between the decay time and how many units remain. Because as these decay over time, the units become smaller and smaller. So through this, I can measure out through 1,000 years how many active actinide units there are, which are, as mentioned before, some of the most radioactive substances and are used for fuel. In this first graph, we can see that 1.5 units are measured, which, if you were paying attention to the other table, is 3.9 to the ninth power of sievels per ton of heavy metals being a part of actinide metals. Sievels are a bit interesting in the fact that they are the unit we use to measure radiation. One sievil is enough to give you radiation poisoning. Two sievels is enough to give you more severe radiation poisoning. 4 and 5 is enough to kill you. And as you can see here, with this one chart, actinide radiotoxicity in the first year can easily kill a human. That's not taking into account that one of these units is thousands of sieverts. And as you see, they slowly decay over time. But let's compare that to MOX real quick. MOX, as you can see, has actinide radiotoxicity far higher. Now let me go back to this. 1.5 is the top for UOX. 12 is the highest for MOX. That is a 9 times greater increase in radiotoxicity. Now, this is obviously very dangerous, and it proves that UOX is a lot safer in waste than MOX. However, there's something we need to keep account. UOX, as mentioned, produces MOX. Taking that into account, we can then understand that radiation doesn't exist in a vacuum. lack of a vacuum that radiation exists in help us understand that it's not black and white between these types of radiations. As as not mentioned, is MOX is actually 50% more efficient than UOX in most situations. However, if that radiation is worth it or not, I would probably have to say no. It is still 3 times more radioactive than UOX waste. So in my opinion, in terms of MOX versus UOX, MOX wins. And I hope that this video helps us understand that radiation in many different substances can change depending on what fuel is used.